Good evening, everyone, or good morning, or good afternoon. What time you're watching this will vary. So, my name is Alan Ferdinand E. Perez, and today I'm going to talk about you with Coulumb's Law. So, first, what is Coulumb's Law? Before that, before that, I'm going to talk about who was the proprietor of Coulumb's Law. The proprietor of the Coulumb's Law was Charles Augustin de Coulomb, and was born and raised in Paris, France, and was born in June 14, 1736, and later died in August 23, 1806. Before he died, he developed Coulomb's law, and we know Coulomb's law today is the unit of electric charge as coulombs. So, what we're gonna talk about Coulomb's law. So, first, I'm gonna talk what the basic concept of Coulomb's law shows. So, we know that matter can be electrically charged from our topics like uh, general chemistry, like that, or what older older subjects from grade 9 or grade 10. But the basic rule is that matter can be electrically charged. This either positive or negative, or it is neutral. So in Coulomb's law, it states that like charges repel. So I'm gonna give an example. Like, imagine this is a positive sign and this is a positive sign. So they don't attract because they are like charges, so they repel each other. Also, it still is true when this is still a negative or a negative, so it will still repel no matter what. So even is positive or negative, they will always repel, and you can't do anything about it. But opposite charges attract. So take for example, this is a positive or and a negative. So they would attract each other. So they would attract each other just like magnet. So next up is we're gonna talk about how to solve Coulomb's law. So in this screen, I'm gonna show what is the formula of Coulomb's law, and you can see there we're gonna find the electrostatic forces between them. So it shows that F equals K Q1 Q2 over R2 squared is the formula of Coulomb's law, and that is the way we're gonna find the electrostatic force. So we're gonna take a sample problem and we're gonna try to solve it. Not try, we're gonna do our best to solve it. So yeah, I'm gonna show you in the next slide. So the next part is we're gonna solve Coulomb's form problem using Coulomb's law and Coulomb's formula. So as you can see in the screen, that's Coulomb's formula. We're gonna solve a problem using that formula. So the sample problem is a point charge of 3 microcoulombs is 12 centimeter distant from a second point charge of 1.5 microcoulombs, and we're gonna calculate the magnitude of the force of each charge. Before that, we're gonna find out what is K. So K is Coulomb's constant, in which 8.99 times 10 to the power of 9 Newton meter squared over Coulomb squared. Remember, that is Coulomb's constant. So we're gonna put all of the given values, that is Q1, which is 3 microcoulombs, Q2 1.5 microcoulombs, and the distance is 12 centimeters. So we're gonna put those values in Coulomb's formula, which will be as seen in screen. So that is where you're gonna put all of the values, and when you try to solve those formula when you try to put those numbers inside of your calculator, that will result in 2.81 newtons. So I hope you guys benefited from this video, and I hope you have a great day. So thank you so much.